Hi, everybody. Like Heather said, I run software at MacStadium. As a developer myself and as someone who's kind of lived in development for a while, one of our goals at MacStadium was to help the people we serve, who are the development community. So Orca was a project specifically crafted to make the development tools available at MacStadium for MacStadium infrastructure better and easier for everyone. So um, again, our goal is to provide infrastructure and make dev easier. Most of our customers are iOS, Mac app developers. And we all know Apple's build system and Apple's build ecosystem is very different from what you experience on non-Apple build processes. Um, we realize we have a special place in the ecosystem because we provide Mac build machines which aren't available in other public or utility-based clouds. And we all know the difficulties with virtualization and management of Macs in general. So helping teams go from small to large scale very easily is always a challenge, and it's something that we strive to make more efficient and better for everybody every day. And that's really why we're here. So in the spirit of that task, we started to try to do more around software enablement and interface enablement for MacStadium. My internal team uses Docker and Docker tools. We use Docker for Mac a lot, and we're used to that kind of ecosystem. And we also, once we build our Docker services, one thing we contemplated as a development team, as we talked about the tools we know and love and how our processes work, was just finding a way to really bring that capability into Mac infrastructure ecosystems so that folks could do kind of the same things they're used to getting with these other services in our data center. So we put Docker controls around macOS. That was kind of the first step to making it viable to have a delivery platform for scaling on Mac infrastructure, but still using common interfaces. And when we attacked this problem as a software team, there were a lot of ideas around how we could automate and orchestrate Mac infrastructure. But one of the things we decided early on was that we really didn't want to invent a specialized, unique, different kind of interface that everybody would have a steep learning curve to address. And realize that Docker and Kubernetes are very, very widely distributed and very, very well liked, so that if we could somehow leverage those interfaces and those technologies to do what we're doing on the back end, that would probably make the ease of use and the capability of this platform a lot better. So that's why we started this way. And basically what we've done is figured out a way to deploy a Kubernetes cluster across our Mac hardware. At MacStadium, we do things a little differently than your typical DIY infrastructure. We're very, very keen on proprietary and best practices around how we stack and rack the hardware with the storage and networking that we use so that it's enterprise class as fast as possible. And then on top of that, we're putting Kubernetes, and on top of that, this is where we're starting to wrap things in Docker containers so that we can use the power of Kubernetes orchestration to manage our containers and our pods, and then that contains the macOS image that we actually ultimately end up using for build processes. So the way Orca really works down at the bare bones when you get to the machine level is that there is Mac hardware. We're very, very purpose built to be designed and geared for genuine Apple hardware. So we're not trying to get in the way or break the model of using genuine Apple hardware for Apple builds. That is a mandate from Apple, and that is something we very much respect. So we put a virtualization layer with the Mac hardware. We containerize that and put it inside of Kubernetes. macOS goes on top of that, and then your applications and your development tools go inside of that. We wire this all up with high-speed flash SAN, but the hardware itself has internal drives, and we'll get into it in a little bit about how we do this, but we do make some opinionated decisions about how we split the images and how we manage storage and data transfer so that we can get the best speed possible out of the Orca platform. So when we rolled this out, beta customers were reporting a 30% improvement build time over their existing infrastructure. This is because typically when you do virtualization, you incur overhead for the virtualization layer. It's what people sort of generically call a VM tax. That takes away from some of the capability of the build machine, which gives you less hardware to work with, which makes your builds go slower. We've implemented a very, very lightweight layer. And again, we've done some things with the way we network and storage architect things. And because of that combination, we've been able to pretty much eliminate that tax so that we get the optimum speed and the optimum performance. For us, we think this is the best way to manage Mac VMs at scale. It's, again, based on Kubernetes. Kubernetes is wildly scalable and very easy to use. And we feel like the tools we've given you will make it super easy to interact with. Again, we're coming at it from sort of a developer's mindset. So instead of trying to sort of force you to build your own data center from scratch in your head, or even with software virtually, we're really trying to attack it from the way we would use infrastructure software ourselves. To that end, we basically put 3 interfaces together to interact with the Orca product. The first one is the one I'll walk you through today. It's a CLI. It's a CLI tool that you download onto your clients. MacStadium is very security minded, so you'll need to connect to your infrastructure via VPN that we provide you to Cisco firewall. But once you're connected, you can download this client. This client will connect to your cluster. And I guess that's a point I need to probably stop and talk about for just a second. While this is Kubernetes, and if you are familiar with Kubernetes, a lot of clouds have Kubernetes clusters, but they are multi-tenant, which means it's one giant Kubernetes cluster, and then you get namespaces or pods off of that. In MacStadium, it's a bit different. Everyone gets their own cluster, so you're operating a full Kubernetes cluster isolated to you. That provides some security benefits and some isolation benefits, but it also prevents any kind of situation where we would have anyone potentially overlapping hardware, which we cannot do. That said, back to the CLI. The CLI is the tool that you'll engage with Orca the most to kind of quickly get up and running. It's very easy to use. You basically download it, set it up, and then use it as a command line tool on your normal command line. We also have an API, and I'll talk about plugins later, but our API is a RESTful API. It lives in Postman, so you can curl almost any command that you see in the documentation here and get feedback so that you can understand. So if you have custom processes, or if you'd like to make your own plugins or your own automations around Orca, the API is there for you to use. And you can always use it in conjunction with the CLI to understand how the workflow would work and then implement it in the API side. And then finally, there's a UI. The UI is a quick way to visualize what's actually happening in the CLI or the API. It does basic commands and functions. It does basic listing. It lets you kind of get a bird's eye view of all your infrastructure and what's going on. And with that said, let me go into a couple of concepts for us real quick so that when I do the demo, it makes a little more sense so that you're not off kilter with some of the terminology. So basically for Orca, we have the concept of a node, and that terminology appears in Kubernetes language as well as other places. But for us, a physical host is a node. It's your CPU and your RAM. And a node is also a node in the cluster of your Kubernetes cluster. So typically an Orca cluster starts with 3 nodes. They're all joined and they're all HA mastered so that they're all highly available and redundant. These are physical hosts as well. Then we have the terminology of a VM. We call the Orca VM the encapsulation of the VM and the Docker container inside a Kubernetes pod. So it is the full macOS inside a Docker container, and that Docker container sits inside a Kubernetes pod, which lands on one of your nodes. So when you're building these VMs, you're going to have the concept of images. So a base image is what we call a full weight template, and that's sort of the foundation of anything you provision. From Orca's perspective, unless you choose to run them long term, any containers you spin up are going to be ephemeral. So there's some there's a concept of the differential from the base to what you're actually running that you want to deal with. So from a concept perspective, what you need to understand is a full weight OS inside of a container is a template, and that's going to live on your storage, not on the node itself, but on the highly available storage. And it's from this base image that you're going to start creating and spinning up what you'll call your running VMs. And then this is what I was referring to, a running image. So it's basically an ephemeral snapshot. This is where some of the scalability and speed and flexibility of Orca come into play. The base image always stays on your storage, and what happens at go is that the differential of that base image gets spun up into a container on the node that it runs on. So what you end up having is an extremely lightweight Docker-esque container VM running on the node while that full weight base image remains on storage. This also optimizes the amount of VMs that you can run on a node because you're not putting the full weight of the base image on every node every time you're trying to spin it up. Once you have these things going, it starts to get into more of a Docker vernacular as to how you can save your images and what you can do with them. So we have the concept of an image commit that basically modifies the current base image with the running image. So if you spin up an image, you put a new version of Xcode in there, you change it or add a couple of browsers, you like the things you want to do in there, you can basically do a commit back to the base image, and that will effectively update that base image. And that base image will be updated for all the images, all the VMs that run off of it. So that's a permanent change to that reference. Differing from that, you may want to create a new base image because you want to keep your gold master in an original state, but you want to make several different versions of that gold master or several different masters for different purposes. And in this case, what you would do is you would spin up a base image, you would modify it accordingly, and you would do a save instead of a commit. That save would basically effectively create a new base image copy. And then when you created a VM, you simply reference the base image that you want to start from to spin up your next container. So you could do base image 1 or base image 2 or base image 3, on and on and on. So this is how you can have multiple gold master versions. So with that said, let's get into a demo. What I'm going to do is show you some basic Orca CLI stuff, and we'll see how easy it is to get started with Orca and have a container running. The first thing we're going to do is just connect with the CLI. So Orca starts everything with the Orca command, and then a verb and an action that you want to take. So Orca login, and it's gonna prompt me. It's credential based. You can have multiple users. There is the concept of an administrative user and non-administrative user. Basically, that affects visibility and control. So as a user, I can see the things that I've deployed. As an administrative user, I can see all the things. So once we're authenticated, we've checked in, and we're good to go. Now, when you first set up your Orca environment, you will need to do an Orca config. And what Orca config is going to do is ask you for the endpoint URL, which is your API endpoint. It's going to request a license key. We're in the demo environment right now, so it's got a pre-populated Orca license key that's just a blank. But here's where you would set your license key and your output style. Once that's done, it sets your token up, it authorizes you, and you're configured. So now I can see that I'm logged in. And I can see the users. So this is a dev environment. I have a dev user, I have myself, and we're in and we're good to go. One of the first things we want to do is we want to do a node list. Sorry. So again, back to the concept of nodes. These are physical devices. They're also Kubernetes cluster nodes. I can see from this example that I have 3 Mac Pros in my cluster. They all have these specific IPs, the CPU and memory. It looks like Mac Pro 3 actually has something deployed on it, and we'll check that out in just a second because I can tell that there are CPU and memory pull downs on that particular node. So from here, I'm going to do a command and then split this off into a separate tab. This command is called Orca Top. Orca Top is going to be the same list view you just saw. However, the difference is, like a true top command in Linux, it's going to keep running. So as changes occur and as things get deployed, you'll see real-time updates and real-time refreshes to that screen. So we'll pull that off to the side here so that we can actually keep track of what's going on while I deploy things. And we're back in. Let's go ahead and see what we have in our image library. So one of the first things you're going to want to do is provide a base image. In Orca, we do provide default vanilla base images in your Orca storage, but most folks tend to like to provide their own ISOs or their own base starting point. So you have the ability to upload your ISO or your image. From there, it can be listed, and then you can use that image to start creating your configurations, your templates, and your VMs. So from here, I'm going to do Orca image list and see what I have. So in this environment, I've got a Mojave image already set up in here and a Macintosh hard drive image. That's just a disk image that's in there. But the Mojave image is a vanilla Mojave image that we have ready to go. So the next thing I'm going to want to do is do a configuration create. So what this is going to basically do is start to create the container and the wrapper around the base image that I want so that I can build a VM and start deploying it. So the command is simple orca VM create config. Now you'll see that the CLI is interactive. So if I don't specify the details of the command that I'm implementing, it's going to do step-by-step help and kind of guide me through the creation and the data and the inputs that I need. So for here, it's going to ask for an ID. We're going to call this webinar Mojave image. I'm going to give it 12 cores and 12 virtual cores. And I'm not going to specify a node name at the moment. So it's creating and deploying. And it successfully created and it deployed. So now actually one of the things to point out here is that command sort of did compound functionality, right? I created a config, which we'll go look at, but I also deployed the VM with that config. So if you'll notice here on the top, what we did is we got a VM deployed on Mac Pro 2 already. So in that one step, I pulled a base image, I created a VM, and then the Orca system, since I did not specify the node name, which I could have by saying Mac Pro 1, Mac Pro 2, Mac Pro 3, simply chose the best available resource at the time and deployed it there. So now I know on Mac Pro 2, simply because I can see the resource pull down from here, but I'll show you another way to know where you are and what's going on, that my config was created and deployed. So now we're going to do an Orca. We're just going to VM. We're going to do an Orca VM list, and we're you're going to see, let's excuse the formatting, let me expand this out and do that again. There we go. So now we're going to see, from my perspective, the VM I just deployed. We see a VM called Webinar. It's got an ID. It's got my name associated with it. It's on Mac Pro 2, like we saw, and it's giving me the ports, and it's telling me it's up and running. So there's our VM. It's alive. We also get an indicator of how many VMs we've deployed and how many we haven't deployed. So again, I used a compound command here that actually built the configuration and deployed it in a single step. You could simply do a create config and then stop and then do a deploy in a separate step. In that case, I would want to check, and what I would see here is that I had a VM created but not deployed if I did it that way. But in this case, again, it went ahead and deployed it automatically for me. So let's go ahead and look at that VM. I'll pull up a VNC viewer for us. And it looks like we are on .5, and port 6000 is my VNC port. So we will pull it over here and log in. Now again, this VM is a base image that we've already gone through the install process. You can start with just the install material, and in that case, what you would get is the macOS install screen. One thing to note that folks tend to run into when they start deploying VMs as well is that if you do an install of macOS, you'll notice here on Orca we have a couple of different ports listed for you for logging in. You have a screen share port and a VNC port. macOS by default is going to lock out the ability to tee into it at first, and you're going to have to go in and configure that and then save your configuration so that you can screen share effectively. It doesn't happen by default. But we also provide VNC outside of the OS and SSH ports so that you can directly access the machine that you're spinning up. But that's pretty much how easy it is to configure a VM for Orca. And like I said, from this point, I can start adding my tools, my special scripts, anything I want to do. And once I have that added, I can do saves and commits. And we'll talk about those now again. But I'll show you with the help. We're gonna go into the Kubernetes stuff in a minute, so I'm gonna kind of walk you through what saving and committing looks like. Okay, help. So again, if you type help, we've got a fully listed help, like any kind of CLI you're used to. But you're gonna see the ability to do statuses and creates, deploys, starts and stops and suspends, deletes and purges. Delete and purge is something I should focus on for a moment as well. When you remove a VM, you can delete it. That will delete the ephemeral VM that you spun up. It will not delete the base image, so it will not get rid of any instance of your base image. If you do a purge, that gets rid of the configuration as well. So if you wanted to eliminate all running VMs and the configuration that they spawned from, you would do a purge. If you were simply trying to eliminate a VM from running, you would do a delete. Obviously, you can start, stop, and resume. There are image commands, and there are Kubernetes commands. One of the things that's very powerful about Orca, again, as it relates to larger development practices, is that this is a fully functioning Kubernetes environment. It's not just a special software environment. Orca is a namespace in that Kubernetes cluster that has the abilities and opinionated structure to manage our macOS and Docker container on the nodes. But outside of that, you have fully functioning Kubernetes nodes that you can do any kind of container builds or any kind of container orchestrations you want. This matters because a lot of folks want to put command and control systems or databases or websites or security tools or other things in the cluster alongside their development tools so that they can manage. And this gives you the ability to do that very, very, very easily. So what we'll do here is I'll show you basically a quick way to do a Kubernetes setup on Orca. So we can do Orca kube account generate this. So what this did is connected to my Orca cluster. It set up sandbox space. We have a concept of sandboxing, and sandboxing is the ability to isolate a node from the rest of the cluster. The reason some folks want to do that, or that you would want to do that in general, is you probably don't necessarily want your containers running intermixed with your build systems, your build VMs. You want the maximum amount of capability out of your build VMs. So you may not want a set of containers that aren't Mac-based running right there with them, because that could take away from resources. They also, if they behave differently, could ultimately impact what your build system's doing. So we have the ability to sandbox your resources off by node so that you can have a node for non-Mac items and then the rest of your nodes available for build services. That said, if you do want to just treat the cluster as a gigantic cluster, you can always unsandbox items and have your containers run intermixed with other containers. What I'm going to do here is take this export and run it. And then once I've done that, I can use my normal Kubernetes controls to see what's in my cluster. So what we're going to want to do now is sit here. Get our Kubernetes command up and running. Sorry, folks, scrolling through some. We're going to apply, I've got a little hello world YAML that I tested before. Basically, it's a little file. It's got a load balancer, a web server, and a database. It's going to deploy a little Nginx container in the Kubernetes cluster. So when I hit this, you're going to see Coopctl goes up and runs it. When I do a get all, we can go look at the cluster. We can see the pods that got deployed. Got our 3 little pods with our pod with Hello Kubernetes. Our service has a load balancer with an external IP address and everything there. And then if I did this right, we should be able to go into our handy dandy Mac VM that we just spun up and open a browser and hit our Hello Kubernetes pod. So we'll go to HTTP. Let's see, where are we going? 10.10.10.92. And we get hello world from our web server. So simple demo, nothing earth-shattering there, except for you see how easy it is to pull non-macOS containers into your cluster, run them, have them work with your macOS containers. They can communicate across the cluster. Again, you do still have all the security controls that you want with Kubernetes, so you can do pod isolation, namespace isolation. You can decide what communicates to what and how. This demo is explicitly set up so that I can have that web service communicated to through an external IP, because the YAML file describes an external IP that routes the AD traffic into that pod. But if I wanted to do containers beside my macOS and not have them communicate, that's a viable option as well. But that's the power of Orca, again, is that you can now orchestrate your Mac containers and your non-Mac containers through the same processes and automations that you use anywhere. Or if you're an all Mac shop and you're used to doing it that way, this kind of gives you the ability to start to expand in those directions as well. But this is a pretty short demo, and I hope you've seen that in almost no time at all. I was able to log in. I was able to create a VM from scratch. I was able to have it up and running I was able to deploy services alongside of it and have those intercommunicate and work through it really, really simply and easily. It usually doesn't take folks very long to get up and running with Orca. That said, this is all command line and infrastructure sort of related. If you're wanting to stay out of that part of it, we also have a bunch of plugins. They make it super simple. So if you're used to living in Jenkins or GitLab or BuildKite, TeamCity should be finishing up in the next 2 weeks. They're available and they're designed so that you simply use those plugins from those environments to engage the Orca environment. They're all capable of using the Orca API to orchestrate VMs creation, VM destruction, spin up, spin down. They have both modes where you can use long-lived VMs or ephemeral VMs depending on your workflow. And then they obviously let you use those orchestration tools to run your builds and your runners as easily as possible. We have these on our site. So Jenkins plugin is public. You can go check it out. Super easy to use. Same with GitLab. Also BuildKite. There's the BuildKite one. You can check them out, see how they work. It's also a good way to kind of get your head around a workflow in Orca. Again, you can go through the CLI and kind of work through it yourself, or you can also go check out a plugin. The plugins are all leveraging our API, so they're going to make the calls that you would make in the order that you would need to make them in to sort of see how things go from an ephemeral or a permanent version of things. And let's see. I guess to round this out, a few other things we wanted to talk about. I didn't show it today, but we're ready with Catalina. It works great. That was it's often a question of, well, how long does it take you guys to set up a new macOS? Like, how long am I going to have to wait before I can test the new one? Is there stuff you have to do? The answer is it honestly took our team like an hour or two to get Catalina loaded in the container. One of the mandates we had when we built Orca was that we wanted to do our best not to interfere with Apple in any way at the hardware layer or at the software layer, but we wanted to make sure we had some really cool orchestration in between that. So we don't inject things into their OS, and we don't do things that break the way their OS installs. So as they put out new OSs, it's simply a matter of injecting them into the Orca container, and we rarely have any significant issues with that. So Catalina is ready to go today. Also, a big question that comes up a lot is, yeah, that's great, but what about T2? We know T2 has problems with other virtualizations. Well, we're pleased to say that Orca works on T2. We worked hard on that. We've got it working. The reason you don't see it up on the site for sale at the moment is that we are testing with our product team in our data centers right now to determine the ideal hardware configurations to work with. And how we want to list those on the site. Obviously, we can customize for a customer's need, but we want to try to provide the best configs that we think everybody will like. So we're working on those right now, but from a software perspective and from an Orca perspective, T2 has been solved and is ready to go. So that means the 2018 Mini and the soon-to-be 2019-2020 Pro will be all good. So I know that's a question that comes up a lot, and people certainly want to have stuff that's future-proof. So thought we'd mention that as well. Just sort of a quick run around on the Coop side. Another valuable thing, and I've got a Kubernetes dashboard. If you've used Kubernetes at all, it's real easy to set up dashboards and do visual monitoring and things. We have other tools like Logic Monitor and other monitoring tools, but you can inject your containers with your favorite management and monitoring tools into the cluster and use them to watch whatever you want. So it makes it pretty convenient and easy for you to use your other tools that you're comfortable with to manage your things. Again, if I'm rounding this out, it's easy to use, and I hope you saw even without Kubernetes experience, before I got to that, it's super interactive and single commands do a lot of things very powerfully. It's very quick to learn. The help will tell you everything you need to know. We have a lot of good documentation. You can actually go to Orca Docs and read through examples and see how it works. It's very software driven. Again, my development team wrote it as if they were going to use it, and they do. So it's from their perspective as a developer and as a developer managing infrastructure. And it's very integrated. Again, we try to work with Apple, work with Kubernetes, and work with Docker, but not be apart or specialized from them. And that is kind of what the demo was going to be today, and the talk was going to be. I'm happy to, at this point, shut up for a second, take a sip of water, and listen to anybody's questions or requests.
Thank you. That was great. Yeah, we do have a bunch of questions that have come in during the webinar, but also just to remind everybody, if you do have a question, put it into the question window in GoToWebinar, and we will run through these right now. First question is, where are the container images stored? Are they in a cluster local registry? Options here?
So an Orca cluster comes with a terabyte of NFS attached storage that is in the cluster, and it is common to the cluster. That's where all the base images are stored. So, and then as a user, you have the ability to upload to those. It's not a registry from a Docker registry perspective per se. It's a directory, but you can make as many copies and versions of things there.
Great. There's a couple questions around VPN. So the first one is, during the demo, you're already connected to the required VPN ticket. And the next question is, I assume macOS has network access as normal, access internet or access resources over VPN we may have set up in the account?
Yeah, and we do have a network team that's happy to help you with all the VPN stuff. That's pretty standard with any, Orca or not Orca MacStadium setup. You get an ASA v5, which is a virtual Cisco ASA in front of your environment. It's configured with an IP plan for you. You can use a Cisco AnyConnect client that's available in that virtual firewall, or you can use an OpenVPN client. From there, you connect. Yeah, I skipped the VPN connect because I didn't want you guys to have to watch me type in a very long serialized password. But yeah, it's literally just connect your Cisco AnyConnect client and go from there.
Great. Can you also run a Coopctl get nodes instead of the Orca command equivalent?
So you can run a Coopctl get nodes or a Coop get all and see your whole cluster. Yes. Orca nodes and what are deployed in Orca nodes are not manageable by Coopctl right now. So again, there is some specialization where Orca is doing certain things that it is beyond or not directly integrated to Coopctl. So I think the spirit of that question is, can I just use Coopctl to do everything? And the answer is no, not specific to all the Orca stuff, but you can use it you can see all your resources and resource utilization through Coopctl. You just can't deploy Orca containers through Coopctl. Orca needs to do that for you.
Great, thanks. What output types are available? Is YAML out supported?
You can get YAML out. We're starting to implement JSON descriptions back from command lines. There are a couple of commands where you can get JSON output from it, and we'll be expanding that. But yeah, I think that's the answer to that one.
Great. Is the control plane running outside of these nodes or on them?
It is running on them. So Orca uses a mesh HA cluster deployment. So the nodes are the mesh, are the masters. They're all masters, and they're all capable of failover. The more nodes you add, the more HA mesh we add to your cluster.
Okay. This one you may have just covered, but just to ask the question too, can you specify an Orca macOS container inside the pod YAML?
So I'm not sure so when Orca deploys a macOS, it deploys it as a pod, and it creates its own specialized pod descriptor with some of the features that we have. Again, I think some of the ambiguity there is that you don't necessarily orchestrate your Orca pod deployments with Coopctl. You do it with the Orca command line or the Orca API versus being able to view and watch with Coopctl. Now, that said, on the roadmap, we are moving more towards a custom resource definition version of Orca, where Orca becomes a custom resource definition within the kube cluster. At that point, we believe you'll probably have a little more kubectl interaction with Orca directly. But at this point, you got to understand that Orca is a customized namespace, so there are some opinionated controls that manage how and when resources get deployed from an Orca perspective.
How does testing the container work if the fork of Docker Orca is only in MacStadium? Do most folks have a dev environment that they can do rapid testing with?
Yeah, you just, typically from that perspective, you just, again, by user, you can have any number of images and containers. So most folks just create a namespace or several namespaces, or have, test users where they can create versions of the containers that they want. You can't download, you can't pull the container out of MacStadium down to your local Mac. For several reasons, you'd have to format your local Mac to use the underlying Orca base layer to even be able to use it. And secondly, we're obviously doing very specific things that we consider with our hardware architecture that would break it on a local cluster. Again, that said, future roadmaps are considering Orca as a software download for hybrid environments. That's probably very late next year, but we are considering things like that. But there's a lot to digest before we go that route.
Okay. So the macOS VM runs in a Docker container, but appears we don't actually ever interact with Docker directly, and we're unable to use Docker files to configure the macOS VM?
Correct. You don't layer it necessarily the same way you do Docker files. It is more of a VM image buildup. Now that said, again, when I was referring to the commit and save actions, that is more of a way that you're kind of creating layers and configurations there. And you can specify startup configurations like dynamic labeling, which is something people care about. But there's a limited amount of things you do there.
Is SIP managed at the image level or the host level?
It is managed at the host level.
Okay. Can I specify a private IP for the VM when I spin it up?
You can definitely control how your IPs are engaged and the security policies around those, via your pod security policies.
Okay. Is self-support for the plugins? Is there self-support for plugins you haven't published yet? For example, can we use Atlassian plugins for Jira, Bitbucket, etc., in advance of you supporting or publishing plugins?
Yeah, so that one of the things we were very adamant about was developing our API first before we even did a CLI or UI. And the reason we wanted to do that is we know there's a myriad of tools and things that people like, and we'd rather give you the flexibility to do it how you want. So yeah, if you want to customize a plugin with the tools that you use based on the API, that's absolutely fine.
Great. Do you have experience running Docker desktop and running images, and what's the performance drop compared to MacStadium bare metal machines?
So yeah, so Docker, I'm assuming we're talking about Docker for Mac, Docker desktop there. And then yes, I have experience with that. That's what my dev team uses, because again, while Orca is building Mac OSs, we're not built with iOS or Swift. We're React and Node and all these kinds of things, so we use that all day long. The performance drop from bare metal is actually not a performance drop. So we do have some metrics, and I'm sure our sales engineers and folks like that could show you some of the reports we've had from beta testing and from internal testing. But again, the way we do differentials and storage splits and the way our networking's set up, we're actually seeing performance depending on the build, and it is very build dependent, that equal or exceed bare metal.
Great. Why use one-off injects and sandboxing instead of Kubernetes ingress and affinity rules?
So you can still use ingress rules. Again, sandboxing is not the panacea for everything for us. Sandboxing for us was a way to tell your cluster not to use a specific physical node. And again, it's a label for us, so it can be taken on or off. So for example, I could sandbox a node, I could deploy n number of containers to that node. No Mac pods would deploy to that node because they would understand it to be the sandbox, and then midstream, I could decide, well, that doesn't matter to me anymore, and I could unsandbox that node and things could deploy however they want. So again, for us, it was a convenience tagging way to sort of isolate capacity from build capacity from non-build capacity.
Great. I know we're at the top of the end of the webinar, but there's still a couple of really good questions. So I'm going to keep going. If anybody has time, stay on, because I know a bunch of people are still kind of waiting for questions. We'll try to get through as many as we can. We have multiple Jenkins masters, one for each dev team. Can we use one Orca cluster for ephemeral Jenkins agents, or will they collide?
So, all right, read that one again.
We have multiple Jenkins masters.
Sure.
One for each dev team.
Okay.
Can we use one Orca cluster for ephemeral Jenkins agents, or will they collide?
I believe that you can use, we might have to look into that, but I don't think there would be a problem using multiple Jenkins masters to interact with the cluster. You do have to have the right amount of resources or you'll get queuing because you can't deploy more pods than resources. But I don't believe if it's handled correctly that would cause too big of a problem.
What's the minimum setup to get started with Orca and Jenkins? One node, which size? Just want to understand how that works.
So usually, right now we define a cluster as 3. So, and you know, that's what we feel like is the best reliable HA setup. So if you start with an Orca cluster, we'll give you 3 nodes, and then you can go from there.
Scale up as much as you need.
Yeah, you can scale up as much as you need. It is potentially possible to go less than a 3 cluster node. We don't recommend it from an operations or software perspective because you start to impact your performance and HA capability, but we understand some folks want very, very small environments, and then I would simply say that is possible. Of course, we can deploy that way. It comes with all sorts of caveats around not having HA and uptime and that sort of thing, and performance potential issues there, but generally 3.
Great. Just so I understand, MacStadium has a private fork of Docker. As far as I'm aware, macOS isn't supported as a Docker image.
Yeah, so again, this gets into and I probably should have spent a little more time on the Docker piece, but no, we do not have a private fork of Docker. macOS is not a supported Docker image either. And what you're seeing here with Orca is somewhere between a Docker image and a full weight VM. So we don't slice the macOS up into pieces and make it Dockerified. We use a full weight macOS VM, and it's virtualized down through a Docker container. The Docker container for us is a configurated, opinionated shell that wraps around the macOS VM so that we can orchestrate it with tools like Kubernetes. So again, I think the delineation there to think about is we haven't built a custom version of macOS that is Docker image enabled, like you would find with a Linux image. It's a full macOS. The lightweight split of it comes when we start doing the tricks with the storage and how we do the differentials. So we're pouring a differential of the base image into a Docker container, which looks, acts, and feels like a lightweight Docker container, but in actuality, it's almost like a linked clone VM or an instant clone VM sort of containerized and then orchestrated with Kubernetes. It's a weird, unholy thing, is the short answer. It's a lot going on there. Yeah. It's not true Docker, and it's not specifically virtualization either.
For the example YAML you ran earlier, did those run on macOS or did they run in a Linux VM?
For the Coopctl?
The example you ran earlier, the YAML.
So again, yeah, it's a Kubernetes cluster in a Linux namespace, Kubernetes Linux namespace. So yeah, that YAML was injected up into Kubernetes via Coopctl and orchestrated there. So yeah, you can use any YAML file that you're comfortable and used to in the cluster. Right. You just can't inject it directly into the protected Orca namespace.
Is there a public roadmap of upcoming features and releases?
We are working on that with our product team, and we'll probably be publishing that shortly. Great. But yes, we just released, so we're making sure we're getting the feature requests and the internal debates all settled, so that what we put out is accurate and not changing every 5 seconds.
And I'll use this as a plug too. if you are interested in learning more about like the release notes we've put out so far and other things that Orca currently does, go to orca.macstadium.com, and that way you can see the full Orca docs and the API and CLI, and that'll also have current release notes, and then like Chris said, we'll add in roadmap stuff as we get it finalized.
And our product team is really, really keen now that this is out in the wild of, again, as we built it, we knew the genesis and the core of what we had to get done. But now that it's out and folks like everybody online asking questions are starting to really come to it to see what it can and can't do. We are very, very, very open and very, very keen to hear your needs and your requests and what features you think would be very valuable. So don't hesitate to let us know what you think it needs to do. We're very actively listening and very, very interested in adapting to that.
I think that's our last question, and of course it comes to money. Do we just pay for the cost of the Mac Pro, or is there an added cost for Orca?
So Orca is sold as a cloud. That means it's the combination of hardware, software, networking, service, etc. So MacStadium sells private cloud offerings. Orca is one of those private cloud offerings. So you would find it in the cloud section, and it is sold as a cloud. But this is the part where I get to play dumb as the technical guy and tell you to go talk to your sales engineer on that one, because they can probably expound upon that and break down the cost factors and that sort of thing a lot better than I can.
Yeah, and the cost of a cloud overall will kind of depend on your needs and what the number of nodes you need and kind of all of your requirements. So we don't have pricing immediately published on the website, but like Chris said, our sales team is standing by to help you put together a price quote for an Orca cloud. Just go to macstadium.com/Orca and you'll find all the details there. And there's only one little PS that came in just now. It said, PS, would love to see the Orca CLI available via Homebrew.
Oh, okay. Well, PS, we can do that. We're big fans of Homebrew, and I think Homebrew is kind of a fan of us too. So I think that's not a big ask, and that's a sure thing.
Awesome. Well, thanks everybody. Thanks for joining us for this webinar. And even though we're going to kind of cut off now and stop taking questions, if you have more questions, please hit us up at orca@macstadium.com via email, or go to our website and fill out any number of the contact forms that we have on the website. Like Chris said, we're really eager to get your feedback and input about the product, and we're happy to answer any other questions that you may have that you think of after we get off here. So thanks everybody.